Number 1, angle C is 84 degrees. Side B is 7.31 and side A is 13.88. Number 2, angle F is 39 degrees. Side E is 44.27 and side F is 30.50. Number 3, side Q is 22.59. Angle P is 31.99 and angle R is 62.01. 4, angle N is 96.35. Angle L is 53.85. And angle M is 29.80. Number 5, angle U is 18.22. Angle T is 138.78. And angle T is 42.16. Number 6 has 2 triangles. In triangle 1, angle Y is 62.16. Angle Z is 64.84. And side Y is 33.22. In triangle 2, angle Y is 11.84. Angle Z is 115.16. And side Y is 7.71. Repeats. Questions. Good. Oh, Kirch. 6? Sure. So, Michael, were you able to determine that this was a 2-triangle situation? Yes. Okay. So I can dispense with those steps then, is that correct? All right. So the first thing I did is I solved for angle Z. So by using the law of sines, I said that sine Z over Z is equal to sine X over X. And then I cross-multiplied, divided, and took the sine inverse. And when I type this into my calculator, I get 64.84. So that's Z1. I can find Z2 immediately by doing 180 minus Z1. That second angle, or that angle in the other triangle, is always going to be supplementary to that first one that you found. So when I do that, I get 115.16. Now I can find Y1 by just doing 180 minus X minus Z1. And that gives me 62.16. And similarly, I can find Y2 by doing 180 minus X minus Z2. And that's where I get the 11.84. Now that I have angle Y in each of the triangles, I can solve for side Y in each triangle. So in triangle 1, I can set up a law of sines. So I can say sine X over X is equal to sine Y over Y. When I cross multiply, divide, and take the sine inverse, I get this. And when I type that into my calculator, I get 33.22. Similarly, in triangle 2, I can do almost exactly the same thing, except for this time my y is, or my angle y is different, but the setup otherwise is exactly the same. And when I type that into my calculator, I get the 7.71. Okay? So really the place that you have to remember is that's how you find that second angle, or that angle in the second triangle once you found that first angle in the first triangle, is they're always supplementary. Does that feel okay? Good. Questions about this worksheet? Okay. On to the last section in chapter 7. Which is about areas of triangles. Now, there is an area formula for triangles that you guys learned in your geometry classes. Anybody remember that formula? Good. It's 1/2 base times height. What's the drawback to this formula? What? So the side lengths are base and height only for right triangles. If you have a non-right triangle, we don't know what the height is. So you have to somehow compute that by hand. Alternatively, we're going to give you two other formulas for area of a triangle in this section that neither one of them is dependent on the height of the triangle. So the first formula is area equals 1/2 AB times sine C. So this is like a side angle side situation in which you'd want to use this. So let's see why that formula works. So I know that area is 1/2 base times height. In this case, we're going to think of B as the base, and H is going to be the height here. The side that the height is perpendicular to is always the base, right? So what I can do is, while I don't know anything about the height, I do know that this is a right triangle, so I could use Sohcahtoa inside of this right triangle to recast the height as one of the other side lengths. Specifically, what I can say is that sine of C is equal to opposite over hypotenuse. And if I cross multiply, I get the height is A times sine C. So when I substitute that value for H into 1/2 base times height, we're left with 1/2 BC sine C. Is everybody okay with the idea that this is basically just still 1/2 base times height? We've just replaced the height as this, like as a trigonometric ratio, basically, right? So that's nice. And obviously there's 3 versions of this depending on which angle you want to use, right? So the takeaway here, as a sloppy looking A, is that the angle measure you're using in your sine is different than the side lengths, right? So if you had 1/2 BC, the sine would be of A, right? So that's nice, although the likelihood you'd be given an angle in your triangle in the real world to find the area for is maybe, less likely than if you're just given the 3 side lengths. So there's an area formula that does that. So for S equal to A plus B plus C over 2, the area is equal to S times S minus A times S minus B times S minus C, all square rooted where we call this A plus B plus C over 2. We call that just the semi-perimeter. A plus B plus C is the perimeter, right? That's just the distance around the triangle. And semi, if you get semi-monthly or something, it's like twice, right? So if it's like half of it, anyways. Yes, Bella?
What is S?
S is equal to A plus B plus C over 2.
What is S? What is it?
It's the semi-perimeter.
Which is?
Half of the perimeter.
Okay.
A plus B plus C divided by 2. So you can see that this is potentially quite a powerful formula in that you can calculate the area of a triangle using only the side lengths, right? This actually has a special name. This is called Heron's formula, named after I can't remember if he's Greek or Egyptian mathematician that is credited with this formula. It's one or the other, I believe. So, how would we derive this? Well, so I want to do this. This is just a pain. I don't want to do it. It's in the book pages if you're interested. It'd be 20 minutes to do it, just because the symbol pushing gets kind of rough. But it's built out of the previous area formula, surprisingly. So let's say we want to find the area for the triangle with angle A equal to 43, side B equal to 10, and side C equal to 27. Which of our area formula should we use here? We're going to use this one, right? Because we're given everything we need. We have the 2 sides and the angle. So if I just plug everything in, what do we get here is about 92.7 units squared. Especially for these area ones, I am going to be a little picky that you make sure that you include a square unit on it. So Please be conscious of that when you're practicing in the homework to make sure you're including a unit, specifically the unit squared for these area ones. So next one, let's say we want to find the area of the triangle with side lengths of 5, 8, and 10 meters respectively. Notice this is a side, side, side situation. So what do we need to do before we start doing any calculation? No. Yeah, we want to make sure this is actually a triangle, because if it's not a triangle, then obviously this is a stupid question and we won't want to answer it. Does this represent a triangle? Yes. Yep, which is what we need to have happen. The sum of the legs must be greater than the hypotenuse. So that's good. So the formula I'm going to use then is I'm going to use Heron's formula. Okay. So the first thing I'll do is calculate S. So that is 11.5. Now, if this was a non-terminating decimal, I probably would use a fraction in my calculator. I wouldn't call it 11.5, but since this terminates, there's no cause for concern there. And then when I type that into my calculator, I get 19.81 meters squared. Everybody okay here? Just a word of warning for things like angle, side, angle, angle, side, or side, side, angle. So in a situation where you have like angle, side, angle, or angle, side, or side, side, angle, those are situations where you might have to solve for a side or an angle first before you can use the area formula. That does happen in the homework on occasion, so just don't be thrown when you look at the initial information, go, I don't have enough information to plug it into one of these area formulas. It's okay. You can just use the law of sines or cosines to find another measurement, and then you should be able to make enough out of that problem in order to solve for the given or the missing piece. Or to solve the area then, right, once you have one more piece. Is that okay? So just as a heads up, that can happen. Don't get thrown. But that's it for chapter 7. So your last part of the homework is going to be 23 through 30. With this kind of wrapping up the chapter, we need to schedule a test date for this chapter. I'm going to tell you what I was planning on, and if you think that something else sounds better, you can let me know, but this is kind of at least the initial schedule that I would have chose. So tomorrow in class, you'll have time to work on the reviews. They've been posted, the review and the answers, for some time. You might have seen that already, but they've been up on the Power School page for a bit now. So that would be what you do tomorrow. And then Thursday, I would plan on trying to do the test. I've put the test description also up on Power School. I think there's 4 solve the triangles. There's 1 where it's a 2 triangle situation. I tell you it's 2 triangles. 2 area ones, and then like 2 story problem kind of situations where you have to use the law of sines or cosines to kind of solve it. But that's the test. If that's fine, then there doesn't need to be any more discussion. But I know Thursday's kind of a quick turnaround on things, and if you wanted to start the next section, delay it another class period, that's fine, but I don't know that it's really necessary. This is, I think everybody seems pretty comfortable in this section. There's not a whole lot of tricky things going on. I would advise just getting it done rather than kicking the can on it. But if everybody's okay, then that's what's up on Power School already. I won't change anything. We can count on that and take it to the bank. Everybody good then? Cool. You guys can spend the remainder of our time in class getting started on this.